Hi everyone, welcome again to my YouTube channel Data Engineering for Everyone. Before we start today's video, I have some news to share with you guys. I have joined Microsoft as Data and AI Architect. In this role, I will be helping different enterprise and public sector customers to help them achieve more into their data journey, data transformation, data migration, and all in all to make their digital transformation into cloud smooth and easy. Right, I will be working with different C-level execs to understand their problem and to solve them using my experience. Right. I'm sharing this news for two reasons. The first reason, obviously, I want to share my happiness with my YouTube family, and I want to thank you all for all the best wishes and blessings. The second reason why I'm sharing this news, because I wanted to say sorry, because I was not so active for last 2-3 months. I was not able to reply to a lot of the comments. I was not able to resolve a lot of doubts. This is not an excuse, but really I was busy with my initial days into my new job. But rest assured, I will be active going further. The second news which I want to share with you guys is it's a big news. It's again a very big news for me. So we have reached 5,000 subscriber on my YouTube channel, and the the love, the appreciation, comments which you guys shared on my YouTube channel and from last 8-9 months and last 8-9 months is amazing. So when I started this YouTube channel, I didn't even dream that okay, I might be reaching 5,000 subscribers someday. But yeah, thanks again, and believe me, I will be working harder, I can say, to meet up to your expectations. So again, thanks again, for all your love, all your support, and let's make this learning family bigger day by day. And thanks all again for all the appreciation. um, Before we start today's video now, one more thing. In fact, let me start it, right? So today's video will be all be about analyzing real-time data, right? Real-time data from smart meters, right? But what smart meters are in reality, right? So let me jump to smart meters first. Um, so we all know we have traditional meters, and when we say traditional meters, when we talk about electricity, right, we have meters measuring the consumption of our electricity. So and this is, I think, applicable to every country, every household in the world. So we have meters like this which will be showing some readings, right? And every meter has some meter number, 1 2 3 4 whatever, and this meter will be connected to your main electricity line, and it will measure how much electricity you're consuming. And then what happen, every month there is some person coming from the electricity department. He will read these numbers, right? He will note it down, and then your bill will be generated, something like this, right? So this is how the traditional meters were working and are working, I can say. So as you can see, there's so many things here, right? You as a consumer are not having proper visibility, first of all, how much electricity you are consuming in different hours, how much electricity and where you can save electricity, what I can say. So let's say, what is the peak time in which you are consuming electricity? You cannot compare, as a customer I'm talking about, as a customer you cannot know the historical data, how much electricity you consumed last year on the same month? Was it increased, decreased? So a lot of things. At the same point of time, we need a person who is coming to your household every month, and he is writing this or capturing this information. He's putting this information into some database, right, into some database, and then some report is generated, your bills are generated, and then the bills are sent to you. So what we can say that this system, and I'm not saying this system is wrong or right, but this system is not efficient, right? So what people come out with, and this is where this article is all about. So unlike traditional meter which only recording your electricity consumption, your smart meter will record all the details of your electricity consumption, right? And any electricity exported onto grid, events, alerts, and instrumentation data related to the power supply at your premises. Each data category, so we will be doing it later. So even like this scenario, I was talking about India. So in India, things are working like this. Might be in Western countries or in another country, in different countries, there might be these meters, electricity meters, might be sending some data right now, and there might not be a person coming to measure this or capture this manually. I'm not aware of this, but this is the scenario as of now in India, right? So what smart meters do, right? So now people think about this problem, thought about this problem, and they thought, okay, let's come up with a solution, right? So what they think about and the solution they come up with, they call this thing as smart meter. Same meter doing exactly same thing. So it has a meter number 1, 2, 3, 4, whatever. Now it has your electricity consumption, right? And obviously it has your electricity consumed voltage, whatever the units are. Then it has other details as well, you know, let's say the temperature of this meter, right? And what else? Yeah, let's say two things, right? The power consumed and the temperature. Now the most important thing, obviously there can be a number of things, we can think about them later, but the most important thing is smart meter is connected to internet, right? And this meter is emitting or sending data to some data hub, I can say, or we can say some IoT hub regularly at a predefined interval. So let's say 1 message per second, right? And then this data hub, or we can say data center, will be analyzing this data on real time and generating alerts, reports, dashboards for end customers like you and me, at the same time for electricity board as well, electricity board, right? So see the beauty of this solution, right? So obviously as a customer, you will have details of your consumption on the real-time basis, or not, or you can see, you know, and you can compare. So you will have dashboards, you can have reports, you can have different alerts, right? At the same time, electricity board can also have the historical analysis. Now they can do, you know, a lot of predictive analytics, a lot of machine learning about the power consumption. They can plan accordingly, right? So let's read about it. So smart meter can send data to anywhere, right? The data can consist of your electricity consumed and your temperature and even different kind of things, right? And then we can obviously we can do any number of things. We can divide the data into 3 parts, 4 parts: peak hours, non-peak hours, morning hours, night hours, and all, right? So this is all it is written here. And then we can, as an electricity board, we can even tell customers that, okay, for peak hours, the electricity rating or the costing for electricity is this. For non-peak hours it's this, and you as a customer are consuming a lot of electricity in peak hours. So if you want to save your electricity bill, please consume less, kind of thing. So they can send this real-time information to the end customers. So this is what smart meters are all about. So now we know that traditional meters in future will be replaced by smart meters, and these smart meters are nothing but your IoT devices, right? Now, what is IoT? Okay, so let's jump to IoT first. So in general, IoT itself is not a new term. It was coined by Kevin Ashton in 1999. So what he was like in 1999, it was like connecting the internet to the physical world via sensors, right? And since then this term has been used to describe the devices that interact with the physical world around it. So IoT has two types of what I can say things, or two. So IoT is made up of two words: IoT. I means internet, T means things, right? So simply it means internet of things. Internet means connected, right? We all know internet means connected. Now when we talk about things in IoT can be of two types, obviously sensors, and the second thing which will be interesting is actuators. So sensors can be anything which sense something and send that information using internet to some data collection or data processing unit, right? So let's say we have temperature sensor into our room, and it is measuring the temperature of this room and sending the temperature to your mobile device. So this is your sensor, right? Sensor is pretty simple. Now what actuators are? So let's say if you have a sensor and it is sending whatever the temperature to a mobile device, and in your mobile device you see the temperature is 31 degrees Celsius. Now what you want to do, well, let's say the temperature is, let me take the practical example. The temperature is 15 degrees Celsius, right? Let's say AC is on and the temperature of the room is 15 degrees Celsius. Now you are in office and you want to turn off the AC, right? So if there is a way, you press some button on your mobile and the AC got turned off in your house. So that thing will be done by actuator. So sensor will send some data and then you will press some button here and some mechanism will be done, and your home there will be actuator which in turn will be turn off their AC. So this is sensors and actuators are, right? So sensors gather information from the world such as measuring speed, temperature and location. Actuator converts electric signal into real world interactions such as triggering a switch, turning on lights, making sound, sending control signals to the hardware and to the power sockets, right? Now IoT is a fast growing technology, and this is why this project is very interesting. It is estimated that by 2020, which is already past, 30 billion IoT devices will be deployed and connected to the internet, right? And it is exponentially growing, right? And when we do a bit of research, the data is a key to the IoT success. And this is where this project will come handy, because we will be doing a lot of data analytics over the IoT devices. And I have already explained this. The T in IoT stands for things, devices, and T is things. That means devices that interact with the physical world around them, either by gathering data from the sensors or providing real-time interaction by actuators. IoT can be of n number of things, but it is mainly divided into four types. The first is your consumer IoT, second is commercial IoT, industrial IoT, and infrastructure IoT. Now I won't be going in details of all these, but consumer IoT refers to the IoT devices that consumers will buy and use them around at home, right? Such as speakers, smart heating system, vacuum cleaners, etc. Right? In commercial IoT, is used in commercial sector in workplaces, such as you can say how many people are in office, occupancy, like these are called occupancy sensors. Then motion detectors, so for example, when you go out of your office, the lights are automatically switched off, this kind of thing. Industrial IoT, the IoT which is used in machinery in factories, right? And the last one is infrastructure IoT. So infrastructure IoT is all about monitoring and controlling the local or global infrastructure that people uses every day. What are different examples of IoT? Smart speakers, which I think everybody has. And when we talk about smart speakers, we can have Google, right? We can have Siri, we can have Alexa. So these all are IoT, nothing but IoT. Then we can have fridge, smart meters, oven and microwave, which are smart now and which are automatically turning off and all, right? We have smart plugs, we have door openers, we have video doorbells, lights, fitness, and everything. Apple watches, Samsung watches, everything is IoT. Yeah, so this is the thing. So basically in IoT you will have obviously the thing which you need to measure. It will send that the information to some IoT sensor, and that IoT sensor will be doing some processing, and it will tell you, okay, the information into your devices. Okay, so sensors we have covered. Now coming to the protocols, so basically the major protocol, the most popular protocol in IoT is MQTT. So what is MQTT? MQTT is a messaging queue telemetry transport protocol. In most of the cases, we are using MQTT as a IoT messaging transmitting protocol. And again, this is not important, but since I'm covering, MQTT is a very lightweight, open standard messaging protocol that is used to send messages between devices. It was designed in 1999 and it became open standard by around 2014 by IBM. So this is everything about what we have covered so far. Let me write it down. We have covered smart meters, right? First thing. Second thing, we covered IoT. Now the third thing and the last thing for today's topic is your project overview, right? So let's jump into project overview. So basically what we will be having in today's project is you will have multiple smart meters, SM1, SM2, SM3, SM4, and so on, right? And this is nothing but a smart meters. So we will be writing a simulator program, right? So this will be deployed into your virtual machine. So this virtual machine will be acting as your simulator for your smart meters. And then these smart meters will be sending two types of information every second. The information, as we talked about, are two things. One is energy consumed, and the second thing is your temperature, right? So we will send two types of information: energy consumed and temperature per second. Now, once this data has been transmitted, now what we're going to be doing, we will be consuming this data using Azure IoT Hub, right? And once this data is consumed, we will be analyzing this data using Stream Azure Stream Analytics, right? And now, using Azure Stream Analytics, we will be doing three things. The first thing is we will be, there will be three streams from Azure Stream Analytics. One is called your cold stream. right? And let's say one is called your warm stream, and the third one is called your hot stream. From cold stream, we will be storing this data into your storage account, right? And from this storage account, we will be writing your Python notebook or Spark notebook into your data factory, right? Into your warm stream, we will be using the Power BI, and we will be doing dashboarding. This is kind of real time, right? And the hot streaming, we will be using two things. One is your Azure function, right? And in this hot stream, we will be doing alerting on your email using Azure function and logic app, right? So how this alerting will be done? This alerting will be based on your anomaly detection. So this is your machine learning anomaly detection. All in all, we will be doing this all things in a single project. So we will be ingesting the data, we will be storing the data here, we will be doing some processing here and visualization here. So it is a full data pipeline, from ingestion, data cleaning, data processing, data visualization, data transformation. We're gonna be covering everything. Let me jump to one step ahead, and let me show you the real diagram. So this is how it looks like in architectural diagram point of view. So we will have smart meters, right? The smart meters, and again, we will be covering this later, but smart meters can be of two things: the meters which can connect to internet and which cannot connect to internet. So let's say we are only assuming meters can connect to internet. We will be using your Azure IoT Hub. From Azure IoT Hub, we will be sending data to Azure Stream Analytics. Stream Analytics, we will be sending data to your hot path, cold path, warm path, lot of things, right? So this is your end-to-end project looks like. And obviously we have already spoken about MQTT, so the whole transformation or transaction or transmission will take place using MQTT. One more thing, we will be covering a lot of details. So this is just an introduction, right? But yeah, everything will be covered in a lot of details. The whole code I will be sharing on GitHub, and I will make sure I will cover each and every component. So at the end of the day, you guys are more than confident to write this code by your own, right? So this is just the introduction again. So don't worry, I will be covering this in next few videos. I'm trying to make these videos bite-sized so that you can digest them, you can consume them, and then you can go to the next video, right? But what I will like from you before I publish the next video, that please share this channel, right? So share it, subscribe it, like it, and comment, so put a comment that okay, what you guys want from me in the next video. Am I going too fast? Am I going too slow? What type of content you like in the next video? Obviously I will be doing a lot of coding. I will be implementing in the whole Azure portal. Python coding will be there, .NET coding will be there. But if you guys want to comment anything else, please do comment. So let's meet next week. But yeah, thanks again for all the appreciation for last 8 months. I really appreciate all your support. Thanks again, and have a good day.